Hello, you are welcome to this class. My name is Dr. Kingsley. In this class, I'll be taking you on Introduction to Alkenes and Nomenclature of Alkenes. Now, if we watch on the board, we see the different words, alkenes, depending on the number of carbon atom. But first of all, what are alkenes? Alkenes are aliphatic hydrocarbons that are obtained from the alkanes by the removal of two hydrogen atoms. Alkanes, therefore, have two hydrogen atoms less than alkanes. Now, because of the removal of two hydrogen atoms, there is the presence of what? Multiple bond, double bond in this case. Now, if we have C, H, 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 C, H, okay, H and H, this is what? Ethane. But if I remove two hydrogen atom, let's say I remove this what? Hydrogen atom, and I remove this hydrogen atom, this will become C, H, H, okay, C, H, okay, C, okay, H and H. Now you see that in this place there is removal of hydrogen atom from here to here. Whenever there is a removal of what? Of atoms on either carbon atom that bears a bond, double bond is what? Is introduced. So this thing is what? Is ethene. So we can now see that what? Ethene have two hydrogen atom less than what? Alkane. And there is the presence of a double bond. Now all alkanes has double bond. The functional group for alkanes is the double bond. That is what determines their reactivity. Also, all addition reactions of alkane is to break the what? The double bond. Now, every double bond is made up of what? One sigma bond and one pi bond. That is one sigma bond and one pi bond. In the reactions of alkanes, it is the pi bond that is broken. Now, having seen this, we must therefore say that what? Alkanes are unsaturated hydrocarbons with double bond. As the number of carbon atoms increases, okay, their molecular weight increases. As the number of carbon atoms increases, their solubility decreases. Now, let us look at the first, okay, members of alkanes. The alkane do not have what? The first member, methane. Okay, there is no methane because one carbon atom cannot form what? Double bond. So we don't have what? Methane. Okay. Now the first member of alkanes is the what? The ethane. The formula is what? CnH24. We have propane, which is C3H6. We have butane, which is what? C4H8. We have pentane, which is C5H10. We have hexane, C6H12. We have heptane, which is C7H14. We have what? Octane, C8H16. We have nonene, which is C9H10. We have decane, which is what? C10H20. So these are the number of carbon atoms, and these are the corresponding what? Name of the alkanes. And this is the what? The molecular formula. How do we get them? The general molecular formula of the alkanes, general molecular formula is CnH2n, where n is the number of carbon atom. So n is the number of carbon atom. That is to say, if the carbon atom is equals to 5, and we put this into the what? The general formula, what we'll be having is C5 H2 times 5. So that becomes what? C5 and H what? 10. And this is what? The pentane that we are talking about. Now, having known what alkanes are, let us go to the nomenclature of alkanes. How do we name alkanes? Nomenclature of alkanes is very simple, but it has rules. What are the rules for the nomenclature of alkenes. Number one is that what? You identify the longest carbon atom bearing the double bond. What it simply means is what? The longest carbon atom must be the carbon atom that is longest but also contains the double bond. Let me say, for example, we have C, then we have C and C and C. If you look at this, what is the longest carbon atom? You have 1, 2, 3, 4 and 5. Okay, we have 1, 2, 3, 4 and 5. So we can number from it anywhere, 1, 2 and so on and so forth. Okay, now, but we have not come to numbering. Now we are on identifying the what? The longest carbon chain. If we have an alkene that is CH3, CH2, CH, okay, then here we have a CH2, CH3. Okay, this is an alkene. Now, if this is an alkene, what is the what? The longest carbon chain. The longest carbon chain must bear the double bond. If we look at this carbon straight, you see that this carbon straight is 1, 2, 3, 4, 5. Okay, let me add another CH3. Okay, this is what? 1, 2, 3, 4, 5 and 6. Now, the longest along the straight path is 6. But if you look at this straight path, the carbon atoms here, they don't what? Have what? Double bond. But when we go towards this way, we have 1, 2, 3, 4. So this carbon atom and this carbon atom bears what? A double bond. So it is acceptable if it is the longest carbon. But that is 1, 2, 3 and 4. But when we go through the other way, this way, you see that what? This way also have carbon atom that bears the what? The double bond. But what is the number? 1, 2, 3, 4, 5. Here is 1, 2, 3, 4. So here is a 1, 2, 3, 4, 5. So we take this what? This part, which is 1, 2, 3, 4 and 5. Why are we not taking the straight part that is of 6 carbon? We are not taking the straight, which is what? Of 6 carbon, simply because those straight form, they don't have what? A carbon atoms that bears what? The double bond. So it's not accepted. That is rule 1. Rule 1 is what? For you to identify the longest what? Carbon atom. Now, if you identify the longest carbon atom, the second thing you do is what? Number the carbon atom. Number the carbon atoms. That is the longest carbon atom. While you are numbering the longest carbon atom, you must make sure that what? That the carbons, the first carbon bearing what? The double bond takes the least number possible. What I mean is this: if I have CH2 double bond CH, okay, CH2, CH2 and CH what? 3. What are where are the carbons that bear what? The double bond. It is between these two carbons that bear double bond. When we number from this side, this will be 1, 2, 3, 4, 5. Where is the position of the first carbon bearing the double bond? Is at position 1. But if we go through this way, this will be 1, 2, 3, 4 and 5. Where is the position of the first carbon bearing double bond from here? It will be number 4. So this one will not be accepted. The other one will be accepted because it gives what? The first carbon atom that bears the double bond the least possible number. Now, the third one is what? When there is what? A substituent. If there is a substituent to, okay, the alkene, we must, okay, number in such a way that the substituent, okay, we have a lower what? Alphabet. But first, you consider double bond in your what? Numbering. Then the second what? Is the substituent. Now, when we have CH3, CH2, CH, then we have Okay, let's say double bond here, and here is a CH2 and CH3. Then let's say somewhere here we have a methyl substituent. This is methyl substituent. Now if you look, the carbon atoms that bear the double bond is this carbon and this carbon. They are the one that bear the double bond. Now if we number from here 1, 2, okay, our substituent is at number 2. If we number 1, 2, 3, 4, our substituent is at number 4. However, we are not using substituent to number our carbon. What we are using primarily is the double bond. The place that will give the double bond the least what? Possible number. So this one is 1, 2. You can see that the carbon atom bearing the double bond is at number 2. But from this side, it will be at number 3. So this way is accepted. So this is 3, this is 4, and this is 5. So when we are naming, because there is a substituent, we must name what? The substituent first, indicating the what? The carbon atom where it is present. So the substituent is a methyl. The carbon atom is at number 2. So this is 2-methyl. That is telling us that the methyl is placed at position what? 2. So this is 2-methyl. Then what is the longest carbon? 1, 2, 3, 4, 5. That is from pent. That is from pentane. So 2-methyl pent. Then you indicate the what? The position of the double bond. The double bond is at number 1, 2, the second carbon. So this is 2-methyl, then pent 2-ene. So this 2-ene is showing that the double bond is at what? At carbon 2. So that is how we name when there is a substituent. You indicate the position of the substituent and name. Then you name the what? The longest word chain, which is pent. Then you now indicate the position of the double bond. The position is number 2, so you end it with what? In. That is a 2-methyl pent 2-ene. Then number 4. Number 4 in the nomenclature is if you have, okay, an alkane that is symmetrical alkane. What we mean by symmetrical alkane is that alkane that when you number from either side, okay, the double bond will be at the same carbon from either side. That is a CH2, CH2, CH, okay, double bond, CH, CH2, and CH what? 3. Now look at this. If you count 1, 2, 3, the double bond is at number what? 3. If you count from here 1, 2, 3, the double bond will also is at number what? At number 3. Now when we have this kind of what? Of a alkane and there is a substituent. Let's say here we have what? Substituent, which is CH what? 3. Now although in numbering we give priority to the carbon bearing the double bond, the one that is what? It will give us lesser number. But in this case now, since from either side the double bond is at number 3, then in that case now we will now consider what? The substituent. So that if we have double bond 3 and 3 here, where is the substituent now having the least number? That is the place where you will number from. So it is best for us to number from here, because from this side the substituent will be at number 5, but from here the substituent will be at number 2. So this is what? 2-methyl. Okay, the longest carbon 2, 4, 6. So that is 2-methyl hex. Then indicate the position of the double bond 1, 2, 3 at number 3. So 3-ene. So that is 2-methyl hex 3-ene. Now number 5 rule. When you have symmetrical alkane in which a substituent is also attached at the same position from either side and they are different substituents, what do? We have CH, okay, 2. So this is CH3 anyway. CH3, okay, you have CH, then CH what? 3. They have CH, you have double bond CH, then CH2, CH3. Let's say we also attach a substituent here, which is a BR. Now, if you look at this, we have what? Our alkene to be symmetrical. Now, if we have our alkene to be symmetrical, because the double bond is at number 3 from either side. Now, we now consider what? The substituent. Here is methyl, here is methyl. What position is methyl from a substituent from this side? At number 2 position, 2. What position is what? Is a substituent from this side is also at number what? At number 2. So equal position for double bond, equal position for substituent from either side. In this case now, what you do is for you to do what? For you to consider alphabetization. Alphabetization in that what? The substituent here is bromo, while here is what? Methyl. Now, because B comes before M, our numbering should now be from this particular end. So we now have what? 2 bromo, okay? Then we have what? 5 methyl. 5 methyl, okay? The longest is 6, so that is what? Hex, okay? Hex 3N. That becomes the name of the compound. Now, number next, another rule, that is number 6. When we have 2 or more double bond. Now, if you are having 2 or more double bond, like when you have CH2 double bond CH, CH2, CH double bond CH, then CH3. You can see from here that we have 2 double bond in this place. How do you name this kind of alkanes? Now, if you want to name them, you start with what? The alka. Alka. Then you have position of substituent, if there is any substituent, position of substituent. Then you now use what? Diene or triene, okay, etc, to indicate the what? The number of double bond. So if there is a substituent, you use what? Alka, okay, position of what? Of the double bond, position of the double bond, of the double, not substituent, position of the double bond. So alka, you add the position of the what? Double bonds, okay, double bonds. Then you add what? Either diene or triene, depending on the what? On the number of the double bond to the, okay, the suffix. Now, if we look 1, 2, our double bond come at number 1 here, but from this side they come at number 2. So the normal thing is this way. This becomes number 1, 2, 3, 4, 5, and what? And 6. Now, how do we name it? We start with the alka. Alka means the number of carbon atom. In this case now is 6. The alka for carbon atom that is 6 is what? Hex. That is the alka. Hexa. Hexa. So you don't use hex because there are more than one what? Double bond. Anytime it's more than one double bond, so you use what? Hexa. So this is hexa, okay? You now indicate the position of the double bond. The first double bond is at number 1, comma. The second double bond is at number what? And number what? 4. So this is a hexa 1, 4 what? Then name the what? Diene. Diene. So this is a hexa 1, 4 diene. That is the name of the compound. You name the word the alkane, which is hexa here. Position of the what? Of the double bond. Then you now have what? Either diene or triene, depending on the number of double bond. Here it is what? 2. So in that case, that is the name. Now, if we have CH2, C double bond, CH, okay, 3. Then you have CH2, then you have CH, then you have CH, then CH what? 3. What will be the name of this compound? You can now see that there is what? A substituent here. You might have substituent at any other place. Let's say we have substituent here, which is a Br. Now, what will be the name of this compound? Now, the first thing is to what? Check the longest carbon atom, which is this. Then you now number it with nearness to what? To double bond. The double bond here is at number 1. Here is at number what? 2. We consider double bond first. So this becomes 1, 2, 3, 4, 5, and what? And 6. So when you number, you now begin naming this compound from the what? From the substituent. The first substituent alphabetically is what? Bromo. At what position? That is 3 bromo. Okay, you have what? 2 methyl. 2 methyl. Then you now start with your alka. Now, after naming the substituents, you start with the naming of the alka. The alka is what? Hexa. Hexa. Then the position of the double bond is what? Is a 1 what? 1 4. Okay. How many double bond? 2. So it ends with what? Diene. So this is what? 3 bromo, 2 methyl hexa, 1 4 diene. Now, that is the 6th what? The 6th rule. The 7th rule in the nomenclature of alkenes is when you have what? Geometric alkene. When you have geometric alkene, if you want to name, you do what? You add cis or trans. You add cis or what? Or trans. Okay, as a, prefix to it. Let's say we have C double bond C. Then here we have CH3. Here we have CH2 and CH what? CH3. Okay, this is H and this is what? H. So because this group that is added to this are at opposite side, either side, it is what? Trans. This becomes trans. Okay, as a prefix. Trans. What is the number of carbon atom? 1, 2, 3, 4, 5. Trans pent what? Pent. It's not penta because it's only one double bond. So trans pent. Okay. How many? 1, 2. 1, 2, 3. So double bond is better this side. 1, 2. Trans pent 2 what? In. Okay. But when you have it in this way, C, H, okay, double bond C, H, then you have CH3, here you have CH2, CH3. The name becomes what? Cis, because the group is what? At one side. So it becomes cis pent, okay, 2N. So that is how you name alkenes. Alright, thank you very much. Please do subscribe to my video, share them.